What up? Let's have a good time today. All right. What is today? Tuesday, October 15th. Now you got a 2-hour delay tomorrow. So October 15th, Tuesday. We're talking about section 2.2, which is contextualizing linear functions. As we begin, who can tell me what does contextualizing mean? Big word, lots of syllables. Contextualizing. Macy?
It means like figuring it out, you know?
I like that.
Analyzing it.
Straight to the point. Figuring out the context. Context means the situation. What's going on in real life. I just want to quickly go through. You were supposed to read and highlight. Okay? Share with me the things that you felt were important in this reading.
The first little section there.
What about it?
I just highlighted the whole thing.
The whole thing? Last unit, we defined a linear function in several ways. So you said a function whose graph is a straight line. Okay? A function whose rate of change is constant. A function whose equation is in the form y equals mx plus b, where m represents a slope and b represents the y-intercept. Okay, that's all important. Those are all things that we talked about. Can we add something else in there? Was there something else that we talked about that was part of the definition of a linear function? There's something important. Yes, sir? Well, that's a function. You're absolutely right. Each input has exactly one output. That is the definition of function. But I want to be a little bit more specific to linear. Zyler?
The next sentence below it.
What's the next sentence say?
We'll now begin exploring the different aspects of the linear function and how each piece affects function.
No, this is I would call this another definition of what a linear function is. Blessing? Well, that's already highlighted. That's the second one. This is one that's not listed there. What else did we say? And I'll give you a hint. Dog squatting. Well, that's not a very good hint, Coach Herman. Yes, Blessing. Oh, that's the first one. Function whose graph is a straight line. Althea? Say again. Quadratic. She's on the right planet, that's for sure. Quadratic. All right, what's dog squatting? How do the Indians name their children?
Oh.
The first thing they see when they come out the tent, right?
Oh.
Remember that story?
Yeah.
Okay, and then we went on to say how equations or functions are named. How are functions named? By their degree. By their degree. So we're calling these linear functions. Well, what are linear functions then, Anthony? Very good. So how about we add that in there right there? Let's go. I'm going to make this big. A function to the first degree. There. I added it in. Now I highlight it. Oh, that was really cool. I was able to write it and highlight it. Usually when I write stuff down and highlight it, it smears the ink. But this one didn't. That's really cool.
Because you're on computer.
Yeah, I guess so. All right, something else that you highlighted. Something else that you found was important. Mr. Sable? Down here. Very good. So the input is the independent variable. Look, I skipped that one little phrase, the thing we start with. You didn't have to, but I did. And dependent variable, that means the G is the dependent variable. What's the G? The dependent variable is the output. Well, we've talked about that already, haven't we? That's good. All right, something else that you found that was important. How about the next paragraph or next set of paragraphs? Yes, sir? Uh-oh. What's happening? What's happening?
Cat.
Let's try again. Crash, bang, boom, bomb. Do 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 do. All right, we're live. Here we go. Something else that was important in the next one. Come on, you already have it highlighted, so just look.
I have the independent variable is the variable that can be edited at least within the domain.
We're at.
Yeah.
This right. Okay. The input, meaning the C independent variable. Where are you? Here?
Like first sentence of the first paragraph there.
Oh, the independent variable is the variable that could be anything, at least within the domain. Okay, that's a good one. Good. Somebody else. Skylar?
The first sentence on the bottom right there says the number of months and is the input or independent variable.
Okay. Somebody else. All right, I want to highlight something. I'm going to use pink here because I want to make a definition. I want to, not a definition, but I want to help you with this. In the standard equation form of a linear function, okay, y equals mx plus b. I've got a problem with that. I've got a serious problem with that, and I want to share. So you're going to want to write this down. Okay. First, we already know that linear functions is to the first degree. Okay, you already know that. But y equals mx plus b is called what? Who remembers the name? Taylor? Very good. That is slope, intercept, form. Now, this right here that I just highlighted in pink called it standard form. It is not standard form for a linear function. And what I'm about to say is very confusing. Okay, because a little bit later, we're going to talk about polynomials. Later in the year, we're going to talk about polynomials. And we'll talk about polynomials, get your terms lined up, make them high to low. Okay? That's standard form for 99% of the things that we do. We want all of our x variables on one side with your terms lined up high to low. What I mean high to low is the highest exponent all the way down to the lowest exponent. So in one case, like for example, if I give you y equals 2x plus 3, in the essence of polynomials, this is standard form, okay? In the essence of polynomials. However, when we talk about linear functions, standard form is this. Ax plus by equals c. Ax plus by equals c. Some things have to be true. A, B, and C must be integers. Oh boy, what does that mean? What are integers? Yes, but more specific. Whole numbers. A little bit more. Integers are positive and negative whole numbers. And zero, of course, but zero is part of the whole numbers. In other words, A, B, and C, these three can't be fractions or decimals for it to be standard form. Well, that's good because we don't like fractions and decimals anyhow, right? The other thing that has to be true is A must be positive. Everybody write that down somewhere. Now that's all I'm going to talk about that for now. Okay? Just boom, introduction, standard form for a linear function. It basically has the x and the y on the same side. We're not going to work with this a ton this year, but we will have a point where we'll throw it in and we'll throw it at you a little bit more. I just didn't like the fact that we called this standard form. So I want you to, where it says standard form here, I want you to cross that out, and I want you to write slope-intercept form, or just slope-intercept form. In the slope-intercept form of a linear function. Okay. So we're crossing out standard equation. We're writing slope-intercept. Okay. There's going to be enough confusion in many of the things we do. I don't want that to be one of them. Cool? All right. Anything else? How about the next section? Slope or rate of change? Something somebody highlighted there. Don't everybody speak up at once. Emily?
100 grapes grow for every one branch.
100 grapes grow for every one branch. That's my rate of change. Good. Anybody else? Not much highlighted there, huh? Okay, Stallings?
We need to find the slope by counting the rise and run.
Cool, where's that at?
In the bottom paragraph.
Very good. Find the slope by counting the rise and the run. Excellent. Somebody else? Yes, ma'am?
The middle paragraph on page 70 is the last sentence.
So we write the rate of change as 25 over 3? Good. Next page. Initial value or y-intercept. Note that the initial value is 4. Somebody else. Brian?
The initial is given in the equation as the y-intercept or p-value when y equals x plus 2.
Good. At first line. The initial is given in the equation as the y-intercept or b. Okay. Good. Yes, sir? This first paragraph? The whole thing? Once you know all the pieces, it's simply a matter of putting them in the right order. Since a linear function can be written in the form y equals mx plus b, put the equation in that form. Remember that y is the dependent variable or the output, x is the independent variable or the input, m is the rate of change or slope, and b is the initial value or y-intercept. Cool. Good. All right, so let's talk about all of these things. Let's see here. I want my Google Keep. How we doing on time? So that's a lot of stuff. What is a linear function? Ryan? Okay. It's to the first degree. Yep. What else is it? Come on, somebody, quick. Emily. It's a straight line. What else is it? Linear function. Straight line. First degree. Good. Constant. Rate of change. Can I say rock? Is that okay? Rate of change. Good. Y equals mx plus b is our favorite form. Correct? What are those parts? B is the, m is the, x is the input, right? And y is the output. So now I just gave you 4 names. Give me 4 more names for the same things. Another name for output. Very good. Dependent. Another name for rate of change. Slope. Another name for input. Independent. Variable. Another name for initial value.
Starting point.
Yes, but I like y-intercept a little better. How about you? Okay, can we give another set of names? Is there any other names? Another name for dependent variable? Oh, there it is. Range. Another name for the rate of change? What's that? Very good. Rise. Overrun. Another name for input or independent variable? There we go. Oops. I don't know what I did there. It's not a domain, it's a domain. Another name for the y-intercept. There we go. Constant. That's where confusion comes in. Look at all of those names for the same thing. Mr. Martis? Mr. Bunting Martis.
Browning.
Bunning Martis.
Browning.
B-R. See, I can't even say it. Running.
Browning.
Is he speaking English? Like running, but with a B in front of it?
Sure.
Running.
Oh.
Browning.
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 Brawning. Yeah. Brawning.
Yeah.
Brawn.
There we go.
Brawning. Brawning Martis.
Yeah.
Zeiler. Zeiler Brawning Martis.
Right.
What's your middle name?
Michael.
Zeiler Michael Brawning Martis.
Right.
All same person?
Yeah.
Does nothing changes? It's a lot of different names.
He has 2 identities.
He has 2 identities. He's multiple personalities, huh? Super guy in both of them, isn't he? This is where confusion comes in. Usually when people pick on you, it means they like you.
No, that's
What?
not the case.
Hey, I have a girlfriend.
Ah.
No, that's not the case.
That's a lot of stuff. But if you can identify it, know that all those names are interchangeable, everything becomes a lot easier. And in this format, y equals mx plus b, and if we know what the input is, we know what the output is, we know what the rate of change, we know what the initial value are, this stuff becomes somewhat easy to do. Okay? Let's look at your first problem. Okay, your first problem. Oh, where'd it go? Where did it go?
I'm gonna check if we like.
Sure did. Come on. It won't. There we go. There we go. So, identify all of those parts. Okay? A 2.5 foot rocket's distance traveled in meters based on time in seconds is modeled by the following functions. Well, one thing that's really beautiful here is that they already give you an equation. Doesn't that make it really, really easy to do? What is my dependent variable? What? Time or T. What is my, I'm sorry, my dependent variable, not independent. That's wrong. It's not T, it is D as in dog. The distance. What is the independent? T, the time. What is the rate of change? What is my initial value? What is the equation of the line? Now, in context, what does that rate of change mean? Well, we're talking about what? Rocket. It's 2.5 distance traveled in meters based on the time in seconds. What's that 5 represent? Meters per second. It went 5 meters per second. What's the contextual description of the initial value? What does that 2 mean in context? Brian? What is it we're looking for? We're looking for the distance, right? Then we just said that it's going to go 5 meters per second. That's our rate of change. And the initial value is 2. Yes. It stood 2 meters tall. Really?
I think it might have started 2 meters.
Started 2 meters where? Off the ground. What, it was just floating there?
No, there's a stand holding it up.
Yeah, it's just a stand, right? I mean, every rocket is shot off of a platform, right? So, what's the initial value? It's 2 meters off the ground at launch. Most likely a platform. That's the context. Do you think you can do that? Well, that's if it's an equation. That was easy. Let's look at number 2. Oh, looks like I already did number 2. Don't look away. Quit looking at it, Alex. I see you. My computer is really slow whenever I try to cast and record at the same time. All right, 6. The cost of 6 people to travel with taxi in New York based on the number of miles driven is shown with the following graph. What's the dependent variable? How do you know? C. Who can tell me how you know? It's on the Y. It's right here. This has to be my dependent variable. Did somebody else find a different way? Did anybody find your dependent variable a different way? Yes, sir. Cost of 6 people to travel. The cost It's based on the miles. So this is based on that. So this one depends on that. You could find it that way. Let me ask you, say, since you found that way, were you surprised when they said it's on the y-axis? So okay, you were. A lot of times we look at things one way, we see it that one way, and somebody sees it another way. What are they doing? Sometimes we don't understand that. There's two ways to figure it out. Either one, look at the situation, which one depends on the other, which one caused the other, or something like that. Or we look at the graph, the x is always the independent or the input, and the y is always the output or the dependent variable. So what's my independent variable? M. What's my rate of change? How do you get that? How do you know? It doesn't say that anywhere in the reading. Blessing. Use a graph to find slope. Here's a lattice point, and here's a lattice point. There's a lattice point. We all remember what I mean when I say lattice point, correct? So from any of those lattice points, I just count my rise and my run. I run 1, 2, and rise 1. So my rate of change is 1/2. Okay, what's my initial value? How did you do that? It's on the graph right there. My initial value is my y-intercept, right? So now, can I make the equation line pretty easily? C equals 1/2 m plus 2. I just put it in the form y equals mx plus b. So now in the context, what's the rate of change mean? And cost per mile. How much is the cost per mile? $1 for 2 miles. Now I write this a couple ways. I say it is $1 per 2 miles, right? Or it is 50 cents per mile. Is that the thing? Absolutely. Absolutely. What's my initial value?
How much it is to
Just to jump in the taxi, they take me here. It's going to cost me $2. $2 just to use the taxi. Cool. The last thing I have to do is situation. Yes, go ahead, Ryan. Because it was right here on the graph. My initial value is here. It's got to be my y-intercept, so I use my graph. So know that it's going to be 2. And it's $2 because it's costing dollars. Good question. Good question. Last example you have to do, or last way that you have to do it, is from a situation. Planet Wiener receives $2.25 for every hot dog sold. They spend $105 for 25 packages of hot dogs and 10 packages of bun. Give a linear function to demonstrate the profit based on the number of hot dogs sold. There's no graph, there's no equation. Here I got to figure this stuff out. First, what's my independent and dependent variable and why? Althea? Sorry? P and H, but which is which? P is what? Good. P depends on how many hot dogs I sell, right? It says P based on. So that tells you it's dependent. Okay, so what's rate of change? I think it's, how many people think it's 25? 225 for every hot dog. So that's going to be my rate of change. And then what's the initial value? Yep. That was a cost. That was out of our pocket, right? We're in the hole 105, so it is. It's going to be minus 105. Excellent. That's important. But we're spending this money, for our business, for our supplies. That's a negative, right? I'm not going to make profit if I make more than that. Yes.
Do you know the dollar sign is on? For his money.
Sure. Maybe. Don't have. I mean. So what's my equation in my line?
E equals 225 H minus 105.
Okay. So what's the rate of change? 225 per hot dog, right? What's the initial value? Good. It's the minus 105 we spent for, is it okay to say supplies? Contextualize the linear function. Contextualize the linear function. I want you to finish the evens for tomorrow. Finish the evens tomorrow. If you would flip back as I come so I can see your highlighting. Everybody did it. Makes my heart happy, Alex. Makes my heart happy. Good job today, y'all. See you tomorrow.